agenda today. So today we don't have video. Instead, Shole is going to talk you about his experience in the class, and then he earned an internship and those stuff. And then in the end, we'll also not have a group discussion. Instead, you know, probably we'll try to finish chapter 14, because that's our last chapter, which is also a conceptual topic. So no programming involved. Well, less programming involved, I guess. Okay. All right. So let's start. So this is the problem we did last Thursday, right? So this one actually um, really good. If you do this one and try the last part, and then kind of you will feel like, okay, so you realize how hard to crack the RSA password with current computing amount. Excuse me. Somehow I got a frog in my throat. Okay, so that's the main objective, to realize that it takes a very long time to crack the RSA encryption, which is the asymmetric key cryptography encryption. Okay, but we are not going to get the more advanced prime factoring algorithm, which is more efficient than the one that simple factorization. We're going to use a simple factorization algorithm, which is the simple based on simple division. Okay. All right. So all right. So what is the input we have? So let's do some understanding over here. So I'm going to actually copy this part of the code. All right. So what is the input?
Integer positive number.
Yeah, integer positive number is an input. And the output is, yeah, yeah, right. So all the factors of the numbers. So there's a restriction, which is void one and the number itself as factors. Okay, and you can categorize that as a restriction. Okay. So let's do so basically, so we're going to rely on the simplest factorization algorithm. And what is it?
Check if a number is if there's a remainder after you divide
Yeah,
that number, move to the next number.
and then check that is 0, right?
Yes.
So basically, so what do we use for checking reminders? Reminders? Modulo, right? So if the modulo of the number division by the numbers below, right, and it's actually a factor. Okay, so let's do a few examples. So we're going to take the example number 30, right? So I'm going to print them. Okay, so print 30. Okay, and modulo 2, right? So this will return 0, right? So we're going to go to next one. we're gonna try cube actually. So 3 also works, right? That also 0. So if we try 4, well, it's not 0, right? So that it's not a 0. And then if you try 5, you'll see it's a 0 because 30 5 is a factor of 30. And if you try 6, it'll be a factor, and then 10, right? Which one is the last one?
15.
Yeah. So basically 15. So basically all we have to do is, right, starting from 2, right, go all the way up to 30, right? Or do we have to go all the way up to 30? Um,
No, I guess no. The largest possible factor would be half of the number.
yeah, so in this case 15, right?
Yeah.
So then to make sure it's to be safe, we can go one above that and we can stop there. Okay, so that means we don't have to check all the numbers all the way up to the given number, in this case 30, right? You can simply stop at the half. Okay. All right. So to basically that means we start with 2, and then we basically go to 3, go to check, and go to 4 and check, and go to 5 and check whether it's divisible by 5, and likewise all the way up to 15. And we know that after that 16 would not give you a whole factor of 30, right? So for example, right, so if you print um, this one from 16, right, we'll get 1, right? So basically we say that 1 is not a factor, right? So this is a um, basically this is above, so basically we can say 16 is not a factor, okay, because it's actually um, to to be able to see it as a factor, we should at least get 2, right? Okay, which is what 15 gives us. Okay, all right. So all right. So let's that means basically we need to loop over starting from 2 all the way up to the middle of the number, and then check all the numbers in between, and then check for this modulo to become 0 or not. If it is 0, then that number is a factor, otherwise not. Okay. So what are the matches for this one? I would say what I mean, there are no exact matches, I think, right? I would say range based for loop, right? Range based for loops. But for modulo, we got couple of, right, the swap first and last, and also reverse number, right? So those are actually, so modulo, which is reverse, and then swap first and last. Okay. All right. So yeah. Okay. So let's write our plan. So in step 1, input this one, integer positive number. Step 2, okay, right? So now the for loop, right? So for, okay, for number in I would say numbers, right? Numbers in range range from 2 to this, yeah, this guy, right? Right. I would say half of, right, to half of plus 2. I'm going to add 2 just to make sure it's actually we include because ranges are exclusive, right? So now 2.1, basically now we need to check the condition, right? So if, right, if this this number, right, so how do you check? If modulo of, right, if modulo of this number by numbers, right, is equal to 0, right, then 2.1.1 print, you need to print the number, right, print numbers. So print numbers. Okay. And there's no return statement for this one, right? So because we are printing those numbers, right? Okay. So let's quickly write the code for this one. So this is our algorithm. Just print them. Okay. So def, I would say print factors. The input is this one. Okay. So the doc string prints all the factors of number from 2 to, okay, okay, starting from 2, let's say. All right, so for loop, right? So for, right, numbers in range 2 to half. So so range, how do we find the range over here? 2 to, what should be the other number?
Positive integer positive number divided by 2.
Yeah.
Plus
So what division should we have to use?
floor division
Yeah,
or
integer division, right? So why? Because for example, I'm gonna put this over here for now. All right, I'm gonna pass over here for now. So let's say, like, if you want to, right, print a range, right, and let's say range of 5, this would not print the numbers, right? How do we print? How do you see the numbers in a range? We covered this in week 8. See that this is not helping, right? I just want to explore what are the numbers that this range generates. So to see them, to see those numbers, You can loop, but the let's say the easiest way to see them is generate a list out of it. So you passed this to list, right? So the reason is basically when you create a range, Python doesn't generate those numbers. It actually create a formula and then remembers that formula in the memory. And once we demand the range numbers, that's when it's actually use the formula and then give us the number. So it's actually a optimization strategy. It doesn't generate all the numbers at once. Only when we request those numbers from the range, generate them using the formula. Okay, you can check the documentation. It's a really simple formula that we learned in high school math actually. Okay, so basically you have to see those, basically we have to demand those. So I would say we create a list to generate those numbers. Okay. All right, and this range generate 0 to 4, right? So but if we put like this, right, so now it's a syntax error. Okay, why is a syntax error now? It's a type error because range input should be integers. Okay, so you cannot use a floating point number here. See that it's a type error. Float objects cannot be interpreted as an integer. Basically, range expect all the inputs as integers. So you have to make sure they are integers, not floating point numbers. So that means we'll have to put over here integer division by 2, and to make sure our range is inclusive, I would say add 2. Okay. All right. So and then over here we need to have the translation of this part, right? So if so modulo by this one, so that means this number, right? Modulo by, so this basically this how do we read is basically modulo of this number by numbers, right? Because for loop generate those. If that equals to 0, right? Now it's a factor, so we're gonna print it. Okay, print numbers. That's it. Okay, so this is our simple factorization code. Okay, so I think I made a mistake. Where is it? Oh, still not. Oh, right here. Okay, that's okay. Well, we change this to this. All right. So let's call this function for 30. So do we have to print again? No, because we are printing inside our function. We just need to call it, right? And this, let's say 30. So we got 2, 3, 5, 6, 10, 15. Okay. If we try, so let's try 243. So these are factors of 3 actually. All right. So we'll get 3, 9, 27, 81. Okay. Okay. So if we try one of those numbers that I have given, right? So let's try this one. I'm gonna do it over here. I think this one takes time. Yeah. Because they might time out this one. Okay. So this is, I mean, this is a good. I mean, that's why I actually gave you a warning. Yeah, killed. Okay. So because it's a free tool, right? So they have set time model limitation to avoid misuse actually. Okay, so for example, otherwise people will use this to run all sort of things, right? You can even use this to predict even stock market, right, to make money, right? So they want to avoid those, so they actually have set those limits. Okay. All right, so I would say, so that's fine. So we'll actually all right, so the next one I asked is this, right? um, right, modify your function to return the two prime factors of a semi-prime. Okay, so let's do that. So I'm going to start with this algorithm. So this is plan 1. So I'm going to modify this plan. We're going to still rely on simple um, simple factorization. Now this is a semi-prime number, right? The input is going to be a semi-prime number. Okay, so that's going to be the input. Okay, and then the for loop is also same. So for numbers range of this guy, right? And again, if modulo, so the way basically we need to return these two factors, right? So which are prime numbers. Okay, so to return, how do we return two things from a function? You can use a tuple, right? So now the only the thing is, we know this is a semi-prime number, right? So there's only two factors, right? So do we have to continue looping then once we find a one? We don't, right? Because we find one. So for example, let's say 15 is a semi-prime number. Why? Its factors are 3 and 5, which are prime numbers, right? So I think it's is it the smallest semi-prime? Yeah, right? Yeah, 7 is not a no.
6.
2 and 3. Yeah, yeah, you're right. 6 is the smallest. Well, yeah, right? Yeah, 1 is not a prime. So, yeah, 6 is the smallest semi-prime now. 2 and 3. Yeah, 2 is a prime, right? Yeah. So, so basically, you find one, and you know that the other is the division of the number by the found one, right? So, for example, if the semi-prime is 15, we will find 3 first, and the next one is 5, which is 15 divided by 3, right? So that means we can basically, now we can return from our loop over here. Okay, so I'm gonna change this to this. Okay, and then over here we can directly return. So then that means basically once we return from for loop, that means we are basically done with the function at that moment. Okay, so return, right? So it's a tuple, so return numbers. And what is the next one?
Semi-prime number.
Yeah, so what division should that be? It doesn't matter in here, right? You can do integer division, or you can do regular division, which is fine as well. Because again, right, once you find one factor, we know that the other factor is the semi-prime number divided by the other one. Okay. Okay, so that's it. So let's convert this to code again. So we're gonna basically go over here. So this one, I would say find prime factors. Okay, and then here it's actually going to be this one. Semi-prime number is the input. Okay, so this is going to be semi-prime number is the input. So this one basically returns the two prime factors of um, semi-prime number. Okay, so for loop is the same. Okay, and instead of this, we're gonna have return. Okay, it's a tuple. Okay, so numbers comma. So we are translating this line, guys. Okay, we're translating this one. Semi-prime numbers divided by this. Okay, and it's a tuple. You don't need to have I recommend, comma separated things, list of things. It's considered a tuple in Python, so I recommend removing the parenthesis. Which is still a tuple. Okay, so let's run this one. 415. So now we'll have to print to see the value because our function returns a value, right? So, and let's say the same prime number is 6. We'll get, oh, there's a name error. Oh, I think I made a mistake over here, right? So this should be this one. Okay. Yeah. So I got 2 and 3.0. Okay. Don't worry about getting 3.0 because I returned the division. Okay. Instead of integer division, if you want, you can use the integer division as well. It's fine. All right. Okay. So if we try, so this in here, that code, that value will work. So I'm going to take this one, and if we try that, let me put, oh, I can get it over here, right? So I'm going to copy paste this one, get this over here. This will probably run because I'm not looping over anymore. I guess it might, not sure though. Maybe not. Nothing still running. Okay. Oh, that's fine. Okay. So I don't know why the previous class it actually ran. So anyway, so the improvement, all you have to do is, right, so use the code that I have given, this code, right, and run it for this list. Okay, so you'll have to change that this name right here with your function name. That's all, and which is what I have done in here in this my local machine in this PyCharm code, right? So my function name is find two prime factors, and then that's what I actually have in place of that name. Okay, so basically what this code does is it's actually run the function for 7 times. Okay, repeat 7 times and then get the minimum. Okay, the reason is, we'll have to find the accurate time, right? The code runs, but if the processor interrupts the running, sometimes processor does that, right? Because we are running multiple things in the computer, and basically it hold the Python code running and then do something else, but the time is still running, right? So that means now it's not going to be accurate. So that's why I am repeating 7 times and then get the minimum, so that I can reliably say, okay, this is the the best time that I could take. Okay. All right. So basically, and then I got this one. Okay. So this is, I ran this one when I was coming to college today, and I got this one. Okay. So this is the k value, which is I asked basically right here. The k value is right. So the basically it's the um, bit length, right? So you can get it from this. So integer class has this method, and you can get the bit length of any integer number. Okay. So our goal is to check that k value for this one, 2048. So that means the RSA uses 248 bit numbers, right? So that's long, that many bits in there. Okay, so that means k is going to be that value. Okay, so what we're going to do is we're going to run it for k this many numbers, right? So this table, for this table, so this is going to be so this is the number, and then bit length gives you k value, which I got from here. So these are the k values in the x-axis, and these are the times I got in seconds. Okay. All right. So let me show you how to get the the fitting. Okay. So I already did this for the previous class. Okay. So you can copy paste. So I'm gonna let me show it again, guys. Okay. So I'm gonna dump this and this. So nothing in there now. So basically, you come to this one. This is a really famous free tool actually. Um, so we have, I ran the code, right? I got this time. So copy this whole thing. All right, and basically dump it in there. Okay, so just paste it. Okay, so you'll get this. Okay, and you can see that it's already kind of blowing up, right? The function. So this is x-axis is actually k. So I'm going to change this to k. Sorry, k, and y is time. So I'm going to change this to time, t. Okay. So this is the graph. Now we need to fit this. We're going to add the fit. So that's, we add the formula, right? So the formula that I want you guys. So since this is k and time versus k, right? So I'm going to use that formula which I asked here, right? This is the formula, right? So here's how you use that for a fitting. Okay, so t time equals, okay, oh, not equals, guys, sorry, this should be roughly equal because we are fitting, so not going to be exactly equal. So I'm going to say a times the constant time okay, t to the power, okay, okay, k by 2, okay, and then plus, see, so why it's not showing up? Oh, I think I made a mistake. This should be 2 to the power, sorry, 2 to the power k by 2. Okay, that's what I asked, right? Yeah, 2 to the power, right? So this is an exponential growing function actually. Okay, and you got a good fit. See that? It's really good, and you can see it over here as well, right? Kind of the fit goes along the dots, right? And then the way I can say it's actually confidently that it's actually a good fit using this r squared value. It's really close to 1. R square 1 means perfect fit. It's fit perfectly. but usually when we are fitting we will not get 1 actually, but we will get close to 1. Anything above zero point 0.8, that they say it's actually good. Okay, so and then these are the value, this is the value for A, this is coming from fitting, right? And this is the value for C. So we found the formula, right? So now, so we're going to run the formula for 2048. That's all we're going to do. Okay, so we actually tried to get it in here, but you know it's actually where was it actually? Yeah, I think in here. I hope we still have that code here. Not sure though. Yeah, all right. So I did that. See the formula. Well, I'm gonna undo a few things. Let's see. Oh no, it's actually so you know it's actually, it didn't give us, it's actually overflown, so you couldn't get the actual value actually. Even I removed this, like a is like, you know, like this, and then this I tried to change a to 1, so become an integer, but still it didn't. So that means this was a really big number. It even overflew. So I think I found in, yeah. So this was, it was a number even bigger than this in seconds. So now if you take this as in seconds, you can divide this by 24 times, 60 by 60 times, no, divide by 365 times 24 times 60 by 60, right, to convert it to um, no years,
Oh,
right?
yeah, yeah, yeah.
And still a huge number. Okay, I think we do that over here. Let me see. Oh yeah, so we did that, right? Even that number is overflown. So that's actually even trillions of years, right? Even more than that, right? So we can say like, okay, so that simple factorization algorithm, I mean, we cannot even think about it. Even with the best factorization algorithm, we still get um, millions, if not billions of years. Okay, so that's a kind of revelation or proof that this is hard to crack using factorization. Okay, all right. That's it. You have to embed this graph, and then the code, just the link for this code, right? And then that embed of this graph. That's all. Okay, guys. And you can see that right over here. It's really fast growing function. See that it's blowing up really fast, but the x value is really increasing really small, right? So if you go to, like, you know, 2000, like that value somewhere here, right? That will be actually really big number over here. That's even not capturing the graph. Yes.
When we submit this,
Yeah.
so we submit our, because like you preferred us to use actual Python because Godbolt isn't like can only go up so far.
Yeah, just yeah, that's fine. Just put the code in there and then put the link,
Okay.
and then I don't need to see, like, you know, it's running or anything.
Okay.
Just it'll actually, you know, it'll time out you, right? But
Right,
that's
right.
fine. You put your code in there, get the link, and then submit.
And then you
That's
just
enough.
hit actual Python and Desmos to link your graph.
Yeah, so basically then to get the graph, you'll have to run it locally and get the data set, and then run Desmos. And here's how you I think you can basically yeah, you can embed code. See, let's see, otherwise just yeah, share graph,
Oh, okay. And then you share the
and
graph
then
with over there as well.
yeah, so you can get a image is also fine. You can get an image, You can print it. Um, yeah, say a snapshot, save and share. Then that'll you'll have to sign up actually. They allow sign up with Google as well if you want. Okay, so I think there was a, yeah, that's those are the technique. I think what's language. Yeah, yeah. Yeah, basically over here, okay, and then you can put an image or I think save and share. You can do that as well. I think that way it'll directly go to this one, not like an image. So you get a link actually, because it doesn't right now. It doesn't give you a link because you are not logged in. That's why. Okay. Once you log in, it will give you a link for the graph. Okay. Either way is fine. Either image or a link is fine as well to share. That's true for the improvement, right? So yeah, got it. Okay. All right. So we're gonna start. So this is where we actually. So we left this one, guys. Okay. So unfortunately, we don't have enough um, time to go over all the sections of chapter 14. Okay. But it's again conceptual topic. So just read and do it, guys. Okay. So I wish I have one more day. I have one more day, but that's for the practice exam. So all right. So this is we left the class with this one. So this is an important topic. Let's go over this one quickly, right? So digital certificate is an electronic document, okay, and basically it allows you. It has the information that you need to log in and to a secure website, right? So not just log in, like access secure website. So we call it a digital certificate, and there's an entity that released this certificate. We call them certificate authority, CA. Okay, they are actually companies. They are actually companies who take some money from you and then will give you a valid certificate, which you can put in your website. Okay, so basically it's a part of public key infrastructure. Okay, so and then could you guys follow me, right? So let's find the certificate of Cybook. So this is how you do it. Click on this dots over here. So you'll get this view, okay, and click on connection is secure, and you will see now there's certificate and saying that it's valid. If it is invalid, Chrome will not allow you to go in there. It will say, hey, this certificate is invalid or expired. Do not go in there. This probably a unsecure thing. Okay. And it's saying certificate is valid, and then there are the other things like connection is secure and stuff. And then if you click on right over here, you will see the certificate. Okay, and there you will see the public key. See that? That's the public key. So remember, public key is public, right? So anyone, in this case, the user, the us, the client, sorry, in this case, sorry, the Cybook is sending the public key away with the site in web data, right? So and then what format is this? Hexadecimal, right? So why it's hexadecimal?
To allow for more variations in keys.
No. I mean, it's a binary number, right? So why we use hexadecimal instead? To simply shorten it, right? So otherwise, this is gonna be 4 times larger more, right? So now we actually shorten it using hexadecimal. It's another utility of hexadecimal. So you can actually shorten it. Let's try one thing, guys. Let's copy this and then make it a string and then find out how many. Let's find out how many digits in there. So I'm going to use this same program. So print, right, length, right, of how many characters, how many binary bits. So how we get 64, right? Right. So yeah, and then if we try, so then a binary number, respective binary number, how many should we have? We'll have to multiply by 4, right? Is it 4? No, no, it's not 4, right? So each, remember we learned that, right, one digit in 16-bit is equal to 4 in 4 bits in this binary, right? Remember
Oh yeah, so
we group them.
yeah,
So then it's multiplied by 4 or something else.
it's 4, I think, so it'd be 256.
Yeah, right. Yeah. So it's 64 times 4, right? 256. Yeah. So um yeah, so we can try actually. So then the 256, yeah, so we can actually we can try this, can actually times this, times, I'm just times, and then dot, and let's find out the bit length. It's actually in here, right? So just taking the bit length of it. So integer class has this method and you can use it actually. So is it why it's decimal literal? I have to use the parenthesis. Let's see, will it work? It's actually 9. Bit length is 9. I don't know, or maybe I was wrong. I don't know. So no, I think I made a mistake. Yeah, it's just the number. Yeah, but anyway, let's just trying this, guys. Okay, this is not what I wanted to show you. Just experimenting with. Okay. Anyway, so one more bracket. All right. So we are over here. So this is a certificate, and if you want, you can get more details of it. Okay, like this. Okay. So it has the um, expiration date and then what algorithm is used, right? See that at SHA 256 is the algorithm, encryption algorithm, and then public key, right? And there's a key for the certificate as well. Okay, so and then more information, all of the information the browser need, and it's actually there. Okay, and then this the detail and this general information of the certificate. Okay. So and you can see that common name CN is the second domain name, right? Remember we talk about domain name parts, right? It's the first domain .com and then the one, the primary domain, and then the secondary one. Okay, so yeah, and then issued by, this is the certificate authority here is actually Amazon RSA. So they actually do that as well. Okay, and you can see that the algorithm RSA 2048 algorithm. Okay, see that? So we ran it for that, right? 2048. Okay, all right. So so let's quickly watch this one and then we'll take our break, guys. Okay, all right. So let's start. So this is how digital certificate works. Okay. All right. So let's say e-commerce website. Let's say eBay. Okay. And they want to sell things on the internet. So it's a first pay some money to certificate authority. Let's say the Amazon people, right? So they pay money, and they will get is the certificate along with the key for the RSA key. Okay, the public key. Okay, so and then basically there's a user who want to do business with eBay. I want to message. So what the eBay does is send this send the private key, not the private key, sorry, send this certificate to the user, right? And let me see the captions over here, right, and then the website respond with the digital certificate as proof of identity and the public key, right? So right, public key. And then once the user received this, okay, right, user now can send the secure data like credit card details and stuff, right, safely through the internet. Okay, and if a malicious entity does the same thing, but the certificate now invalid, right? So this thing would not work. Okay, so see that if the digital certificate is invalid, not trusted, then it's actually not gonna work. Okay. All right, guys, it's 12:03. Let's get our break. All right, guys, so let's continue. So we're gonna basically go to the next chapter. So this is the guys. This is the chapter that artificial intelligence. This again the um, the 14th chapter 14 basically. Okay, this is the last one. Unfortunately, we don't have an entire day to go over this one. So this one is optional, and this is also optional. Okay, this one. So I don't know why it's, but there's no attached assignment from Canvas side. So that means also that optional as well. Okay, so um, and then we have a bunch of topics in this module 14. Okay, so before that, all right, before that, so let's actually listen to Shirley. Okay, so can you share your story? So let me start the beginning. So Shirley start spring 2025, right? With me, right? Yeah, it's, and that was your first semester here too.
Yeah.
Okay.
I'll try to reschedule that.
Oh, you will try?
I'm gonna try to reschedule.
Okay, thank you. Yeah, let's do that. Okay. If you can do it, please do it. Okay.
If they have to, if it's in June, can you pay for my everything?
But I hope they will not.
Joke. No, don't take it seriously. It was a joke. I said like when you pay for my dental,
Oh, okay, okay.
it was a joke.
Oh, okay. Anyway, so he started 25 spring, and after that, starting 25 fall, he became a TA with me. And you guys can, if you want to, you guys can ask him how we apply. He'll show you, and because he also got the FWS Federal Work Study grant as well. And then same semester he applied to CCI internship, got that one as, so we're gonna talk about both of them. And then he's a UC Berkeley transfer hopeful, right? UC Berkeley, right? Yeah. Okay. All right. Go ahead, Shauli.
So I attend.
Okay. Wait. I think you should do get this one. This should go into the, and just use like this. Yeah.
Okay.
Yeah.
So I attend CCSF in spring 2025, and at this time I attend my professor's classes, which is 110A, and then after that semester, my professor sent the email to those students who attend his class asking, do you want to be his TA? And I said yes. And the next semester, I become his TA. What I'm do in this class was being as a in-class TA, as uh, being asked some questions and answer those questions and grade those submissions from the students and giving feedback to them what happened in their submissions and assignments, and based on the rubrics give them feedbacks. And then it was in December, my professor suggested me to participate in the internship, which is the CCI program. And I at this time I contact a few mentors who works in Berkeley lab, and I received 2 replies from those 6 mentors, and they said they can pre-select me. After that, I try to finish my application and complete my 4 essays. I think the most important one would be the research interest essays, which is listed out all of the projects that you're interested in, and the mentor or the some people who work in the specific department, they will notice you so that they will select you. And with the help of our professor, he gave me instructions on how to modify my essays and some details in the applications. I successfully received reply from the program. 2 mentors selected me, and I picked one offer, and I think that's it.